Right. Okay. So I want to recap last week's content first of all. All right. So what I want to cover is the few important things about this topic. So last week we mostly did subtraction, right? We finished with negations. So subtraction, first thing we did, really basic recap, long subtraction, which you guys already know how to do. So long subtraction should be our bread and butter. So, but we're not going to use it too much after this, right? Because you already know how to do this. We want to learn something new. And so the first thing we did was doing a negative subtraction. Now, negative subtraction is a bit tricky. You haven't got your head around it yet. Right, so
I don't see your screen.
oh, sorry, I'm not sharing.
Yeah,
That's my sorry about that. I'm not sharing on there either. So I was writing this down. Okay, you guys see that now, and you can see as well, right, Arjun?
yeah.
All right, good. So long subtraction, and the total tricky one we started on is negative subtraction, right? And I'll give you like an example for negative subtraction is 8 minus negative 5. What the answer to this one be?
13.
13, right? It's a bit unintuitive, but when you subtract negative number, it becomes addition. 8 minus negative 5, same as 8 plus 5, it's 13. And to make a bit more sense, we came up with a new definition. Oh, bear with me. Remember the new definition of subtraction we talked about? A minus B, normal subtraction is equal to what? Remember we defined it in terms of something we already knew, something that was easy for us. In terms of addition, A plus what?
B.
No, A minus B is not A plus B. A plus negative B, the negation of B. And this is really, really important because look, if you use the definition, 8 minus negative 5 is what? 8 plus the negation of negative 5. What's the negation of negative 5?
5.
5. So it becomes the negation and it becomes easier to do all of a sudden. Plus 5 is 13. Same thing again. Right? But even then, even you have something like this though, negative 41 minus negative 12, it's a bit tricky. It still becomes plus, right? Subtracting a negative becomes plus 12. Here was a bit tricky. So I really what I want to do is, some of you already figured this out, some of you already know how to do this, but for those who are still wrapping your head around this at the start, everyone has to figure it out at the start, right? I want you to split up in two things. The first question is subtract from positive. It means the first number is positive. So when you have something like this, we know 41 minus. So the point of this is the first number is positive. So for example, 41 minus 83. First number here is positive, right? This one's up. Most of you find with this, right? 41 minus 83 becomes 41 plus negative 83. You can convert this, or you can just work directly from here and just subtract from this, right? But the tricky bit was when you subtract from a negative number, because 41 minus 83, what's that? Equal to. You don't have to do this here. 41 minus 83 becomes some negative number, right? You guys know how to do that. But the tricky bit was when you, I'll do this one with you guys. So when you approach a question like this, just because I'm going to show that those type of questions are in the quiz, right? So you're going to need to use this. So start with 41. You go until subtracting means going left, or adding negative means also going left. So the same thing. So going left by 83 and cross over. Here I would recommend just switching them around, making negative 83 plus 41 will be a bit easier. And you can solve that, and you get some negative, I think negative 42 is the answer. Right? If you don't know what I'm talking about here, just let me know, because this will be important in the test. Right? All right. Now, what about the more tricky one that I saw a lot more people struggle with is subtracting from negative. So the first number is a negative number, right? And the first, for example, we start with, say, negative 53 minus negative 29. How do you do this? What's the first step here?
Oh, you had to do the negation of 29.
Negative 29.
Yeah.
That becomes negative 53 plus?
29.
Yeah, so there's a plus now. Do you think the number is going to become like a bigger number or a smaller number? Like in terms of, not in terms of like to the left or the right?
It's going to be smaller.
It's going to become a smaller negative. Because you're adding means you're going closer to the, closer to 0. Because you're negative 53, you're still left, right? When you add, you go to the right. So when you go to the right, you get closer to 0. That means you become smaller negative. That's just, no, because you know it's small negative, you do 53 minus 29. Figure out what the value is. And then you put still negative. We get to just figure out the number value from this. 53 minus 29 will be something, carry 1, 13 minus 9 is 4. Plus 4, 4 minus 2 is 2. So it becomes 24. Since it's to the left of the number 0, it's still negative 24. So when you have a negative number, you have to be careful. Just think about, just because you're adding doesn't mean the number is going to get bigger. We're adding here, right? We're adding, but it doesn't become 82. It doesn't become negative 82 because we're going closer to 0. So I know it's addition, but you still have to make the number smaller because it's adding to a negative number. That's the counterintuitive thing you got to be careful. And I'm going to be testing that on the quiz today. Right, so we have a quiz. Arjun, it's on Google Classroom. I just did it this morning. So sorry if you haven't printed it out, but you can take a look. Is that fine with you?
Yeah.
All right. I'll give it to you three. You can have it here. Just give me a sec. I haven't stapled it yet because I had a printing issue. Page. The printing came weird. I don't know why, but page 1 and 3 are here, and page 2 is separate.
I only had 2 pages in the printer.
Is it 2 pages only? Is it like 2 double-sided or just 2?
Oh, it's double-sided again.
Oh, okay, right. So the order is first page is here, second page is here, and the third one is printed in between the on the outside of one for some reason. So that's the third page.
Are we allowed to use long division for it?
There's no division questions.
I mean, I saw long subtraction.
Just for the first 10 you are, last 2 no. Page 1. For some reason this page this is 2. 3 pairs. Just got the weird ordering thing, right? Yeah. All right, let's get started. I'll give this about 12 minutes, 12 questions. We'll share this. Oh, sorry. Hey, Ryan. Sorry. Hey, Ryan. So sorry about this. I think I must have missed you in the waiting room. Hello?
Hi.
Sorry about that, man. Luckily, we didn't go over any content. We just did a recap of last week.
Okay.
So we just decided the quiz now. Do you have Google Classroom on you?
Yeah.
On there's a quiz online. Could you like access that and get started? You don't have to print it out. Just do the questions.
Okay.
Sorry for the late quiz. I just did it last night, very late. And it's 12 minutes to do the quiz. So any questions, let me know. Any wording or
Are we on the third handout or are we still on the same one from last week?
same one from last week. Yeah. So there's only one more handout for this chapter, so I'll release that probably next week. So we'll do division then. We have reciprocals and subtraction here. Sorry, but my numbering is wrong. It should be 11 and 12, but it doesn't really matter much. So, to do these ones first. This is more
Oh,
important.
this one.
So page 3 is like last question, optional ones really. So I haven't taught them yet. That's why. So do the other ones first. So there's two parts, right? The first one's subtracting from positive, the second one's subtracting from negative. So just think carefully distinguish between those two. What's the difference between the two is the question, right? If you can figure that out, the questions aren't too bad. We have 5 minutes for everyone. And Ryan, if you want a couple extra minutes, that's totally fine.
Yeah.
Con học sao đau chân sao?
Ừ.
Đau dạ.
Ừ.
Đỡ chưa?
So just for part C, if you're up to it, no vertical subtraction allowed for these questions. So no long subtraction. Just for 11 and 10 and 11. The other ones you're allowed to. But just for those two. If you're stuck, draw the number line. see where the numbers are gonna go, you get an idea of what's going on.
Isn't it adding?
Yeah.
Like this would
No, for these two. This one.
How much time do we have left?
We're finished now. So the 12 minutes just rang. But if you want, I don't mind another minute. So this was a bit tricky the last couple. So if you want, take extra minute or so. Anyone do the last one? No, it's tricky, right? 11's pretty easy, but so 11, the correct 11. But yeah, the last one's pretty tricky. But okay, we'll start discussing in a minute. But yeah, this is the first 10 questions are really important though, for you to get the concept. So whichever questions you get wrong today, just focus. There'll be, if you have any similar type of question that you're getting wrong, just focus on those. All right. Okay. All right. So we're gonna start discussing now. Ryan, if you want extra minute, we'll just go in the first couple, so they'll be pretty short. So you can keep going if you want.
Okay.
All right. So first of all, we have these 4 subtraction questions. These are relatively not too hard, but still negative subtraction. So if it's a new concept, it will be harder, right? So, okay. So did anyone struggle with this question? 47 minus 86. If you did, it's fine. It's not, you're not bad at math just because you struggle with it. It's just the new, for some people it's a new concept, for some people it's not. So if it's a new concept and you're struggling, please let me know. All right. So 47 minus 86. The answer is negative 39. If anyone got a different answer, please let me know, then I can discuss it. Or if you want an explanation for this. No? Oh, yes, please. All right, sure. So where we start is at 47. Right? And we're going subtracting 86. We're going to the I'll draw 0 on relative to the number line, right? I'm going to the left by 86. Oh, that crosses the number line because 86 is a bigger number than 0. So that's already a bit tricky. So what I need to realize is that I should convert this into addition question. 47 plus negative 86. So when I convert to addition question, I can switch them around. Negative 86 plus 47. Right? And then when I switch it around, because this is a commutative property, I switch them around. Now it becomes a question where I don't have to cross over like the border, right? Where I start at negative 86, zeros here. I'm only going up. I'm adding 47. Therefore, I only need to go right by 47. Right, so plus 47. So I don't cross the border here. I don't cross over 0. So then I know that I'm getting closer to 0, right? So I'm getting closer to 0. That means I should subtract that. Right, because it's getting smaller, because it's getting closer to 0. So I should do 86 minus 47. And that's equal to 39. If this is still to the left, you should do negative. But okay, I'll tell you a shortcut from here on it. If the opposite sides, you should subtract. But obviously, it's hard to do here at the start, right? So you should, when you rearrange it and you see opposite sides here, you know, if it's opposite sign, you should always, like if it's negative plus and negative and addition, you'd subtract the two. Because sort of opposite signs sort of cancel each other out. So it'll be subtraction almost always if it's opposite signs. So if you come to this one now, I'll rub this out now. So even if you don't draw the number line, you just get to here, right? Negative 86 plus 47, you see all the opposite signs. If the second number is smaller, I know I'm not crossing over the 0. then I can, without even drawing the number line, I can be like, what, negative 86 minus 47. So I get rid of the signs and just get 39 again, just by without, even if you don't draw the number line, you can think the opposite signs, therefore they cancel each other out. Right, but the key idea is if it's too tricky to get it around your head, you can rearrange it so that it becomes easier to do. I'll show you another method maybe later on at the end of the chapter to do these type of questions. But sooner or later, those will become more interesting to us, so they'll be fine. All right, so now, what about 2? 24 minus negative 37 becomes what?
61.
61. Anyone have any questions with this? This one?
Yeah.
Please let me know if you have questions. Explanation as to why this is? No? All right. So this is 61. And the reason is because when you subtract, minus becomes, so when you subtract a negative, adds the negation of the negative, right? So it becomes 24 plus positive 37. So negation of negative 37 is plus. So it just becomes addition, and that's 61. It's pretty easy, right? Once you convert it to this. But obviously this step's here. This step is hard. Once you get to this step, it's pretty easy. You just need to think until here, until you go from the first step to the second step. There's a conversion that's important. Right. So thank you for asking, because it seems you feel it's hard to like ask, but it's everyone makes mistakes, and you get the concept, and you're not going to make the mistake again. Right. All right. So the next one is 287 minus negative 1398, and the answer is 4271. Any questions with this? No. And it's again the same concept, right? Subtraction of negative becomes adding positive number. Just add it like normal, and that's a long, easy long addition. That's long. And then 862 minus 1349 becomes negative 487. Anyone have questions with this? No. All right. And it's the same question. So I'd say 1 and 4 are the same concept, which is 4 is a bigger number. So these two are very similar questions. And 2 and 3 are very similar questions, which is 3 is a bigger number, right? So this, if you struggle, if you do got both of these wrong, you're struggling with that concept, come to me after class or something, and we can I'll give you a bunch of extra questions, something like that. All right. So please keep in mind, because if you're getting answers wrong in groups, similar groups, then that's a tricky concept for you. So then please ask me. All right. Okay, now we go to the negative subtractions. So first of all, negative 22 minus 29. What does that become? Yeah, did you say negative 51? I think that's what I heard. And it's correct. Negative 51. Everyone good with that? Right? And remember, how I said opposite signs become subtraction, but since even though it's subtraction, it's at the same sign, it's almost adding towards each other. So it's combining, it becomes a bigger negative number. It becomes addition in the end, but it's the same sign. So negative 22 minus 29 is negative 51. The next one, negative 27 minus negative 12. What does this become?
Negative 15.
Yeah, very good. Anyone, if you have any questions with this, let me know. This is it. Yep. Yep, sure. All right. So here, first of all, our first step again, like last time, when we did question 2 and 4, is because it's subtracting a negative, it becomes addition of a positive number. So it becomes plus 12. Right? So that part makes sense. And then again, since now it's addition, you can draw the number line again, but since I told you before, opposite signs means they cancel out. You can be like, oh, I can do negative 27 plus 2 opposite signs, they just subtract it. So I just do 27 minus 12. Because opposite signs will cancel each other out. And I can do 27 minus 12 is 7 minus 2 is 5. 2 minus 1 is 1, so it's 15. But since negative 27 is a bigger number, even though I cancelled it out, I didn't cancel that fully, this still says negative. It's negative 15, so that. So I started with the number line, but it makes, if you don't have to draw the number line, let's start getting the concept a little bit more, right? Okay, so that's negative 15. Does that make sense? Question 7. Negative 34 minus negative 131. Anyone got the answer to this one?
97.
Yeah, very good. It's 97. Anyone explanation of this one? Because it's a different type of concept. Yep. All right. Good. So ask if you're struggling. All right. So negative 34 minus negative 131. So it becomes negative 34 plus what? If you just do the definition of subtraction. Yep. Which is? So just plus 131. Good. Now, since I said before, in the opposite signs, they cancel each other out, right? But the problem here is the 131 is bigger than 34, right? And when you cancel it out, and then it goes a bit further out. Like if I can draw the number line if you want. You start at negative 34, zeros here. We go into the right by 131, so we go across the number, so crossing the border, right? That's tricky to do in one line. So whenever it's tricky, when it crosses the border almost, I always recommend is switch them around. Since you convert it to addition, you can use the commutative property. So I can just do 131 plus negative 34. And now I can just add a negative, or I can even do, you know what I can do? Another thing, since adding a negation is subtraction, I can just also do, sorry, this one should be 131. I can also just do subtraction here. Because it goes all the way around. You know, the definition is a minus b is a plus negative b. If I start here as adding of a negative, I can convert to subtraction as well. But all the way around. So you can, you can still solve from here. You don't have to do this step, but you can commit like just do normal subtraction here. And you do 131 minus 34 becomes subtraction 1 minus 4. Carry share, bring 1 up. It's 2, 11 minus 4, 7. Bring 1, 12 minus 3 is 9. So it's 97. Right? So does that make sense now? So it's really these three types of questions. 8, 9, and 10 are just the same thing with bigger numbers. Right? There's three types of questions. You start with a negative and you subtract the positive number. So they become addition. Right? And then the next one is you start with a negative, but then you subtract a smaller negative. Then you just need to change the sign and just cancel each other out. So do subtraction. But then third question type is question 7, which is start with a negative, but then you subtract a bigger negative. So you're crossing over. So then I recommend converting to addition, then switching signs, then moving them around just to make it a little bit easier. All right. Okay. And last ones here is this one is negative 1378 minus 3137. It's equal to. You got it right. Question 8.
I got 4,550.
Negative or positive?
Negative.
Negative 4515. Very good. Choose a different color. So that's good. Any questions with this one? No. Even if you got it wrong, you get the concept now, right? It's the same. Yep, sorry. Did anyone say something, sorry?
Yeah, I got a different one.
Oh, what did you get?
I got 4545.
I think that was just, you close. I think that was just, I think it's probably just an error on the arithmetic. I think, is it positive or negative you got?
Positive.
Positive. If you're subtracting from a negative, it becomes more negative, right?
Oh yeah, I forgot about that.
So yeah, so that's negative 4515. And then question 9, the answer is, 895. Any questions with this one? And again, this question 9, same concept as this question. You're just subtracting a bigger negative number from it, so it becomes addition. And if it's tricky, switch them around. And then this question here is, anyone know the answer to this one?
243.
Positive or negative?
Positive.
Oh, close, but it should be negative 243. Because you're subtracting a smaller negative. Right? Because you're starting at negative 834, and 0 somewhere far away. But then you go into the right, because remember, subtraction of negative becomes plus addition. You're adding a smaller number, so it's not big enough to cross over to the positive end. It still stays negative. Does that make sense why it stays negative?
Yeah.
Right. Okay. So I'll again color them by groups. So 5 and 8 are very similar. 6 and 10 are very similar. And 7 and 9 are very similar. So if you got questions wrong in that group, that's a concept you should be struggling in, right? So if you got, let's say you got 7 and 9 both wrong, I mean, that's a tricky concept for you. So please note that down, right? So any concept you struggle with, particularly write them down, and I might give an extra worksheet out if you struggle with that specific concept, right? So I'll release that tonight on top of the homework. It's optional, but if you struggle with the concept, please go over it. Okay, now we go to the problem solving ones. It's problem solving with the associative and commutative property. Question 11. What's the answer to that one? Yep, Emma.
417.
Positive or negative? It's close, but it's negative 470. These two, when you have, no. You're very close. I think it's the idea, but you just gotta be careful because you do a subtraction of 417 here. Right? If you wanna, so you can think of these two as canceling out one way. You're left with a negative 4, subtracting 417 basically. Because if you do this, think like this: 8, 2, 3, 4. This cancels, becomes 0. Subtracting 417 from 0, it still becomes a negative number. This negative sign still applies in front of the 417. And I can explain this more properly if I convert it into addition. This is just sort of a shortcut explanation, right? If it doesn't make fully sense, I'll explain it using the other definition. Is if I convert all of these into additions, right? So 8, 2, 3, 4, 5, 7, 6 it becomes, if I convert them to the positive, the additions, becomes plus negative 417. Yep, plus negative 417 plus negative 8, 2, 3, 4, 5, 7, 6. Right? I convert them all to additions. I'm trying to explain it properly. You don't have to do this. You can just cancel them out fully directly if you get the concept. But I'm just trying to explain it, so I'm going to do it fully and the long way. Right? And since I'm converting them to addition, I can move them around. I'm going to bring the second number, the third number to the second spot. So it becomes, switch these two around. So it's commutative property of addition. I can move them around. Add these to what happens. That's two numbers. Now I've had them. What happens to them? They are negations of each other, right? When you add negations, what happens?
0.
Yeah, it becomes 0. Right? They cancel each other out. That's the definition, right? Negations add together each other. And it becomes 0 plus negative 417. If I add a negative number to 0, what happens to that? You go left, right? Just adding a negative. Does that make sense or feel weird? Because 0 is just like any other number, right? Starting at 0 and you're adding a negative, so going to the left. So you're going to the negative. Ends up being negative 417. So if you want to fully understand it, this is the proper explanation. But obviously, you can do the work and you can take a few shortcuts, right? Did anyone have questions with that? That question? No? All right.
No.
And finally, the last one. Did anyone get the answer to this one?
9, maybe?
Close. Oh, sort of. So what we
I
said?
just did one step of it.
Oh, it's the first step you did.
Oh, I just added like the 3s 9 times. And then got the answer for that.
Oh, okay. Yep. So this one, that's sort of close. I think it's a close idea, but key idea is you could think of this as, you know how when we added in pairs to make it easier? We can subtract in pairs here as well. Look at this. If I paired this 3, because remember, if I convert this into addition, And I can convert it to addition with the negation. So I'm gonna put another bracket on top of that, basically. But I think that's unnecessary. I'll get rid of that. I think I'll explain this way. Sorry. So because if you can subtraction pairs, right? What if I pair this 3 up with this 1? If I pair this 13 up with this 11, then I'm subtracting 3 minus 1, it's 2. 13 minus 11, it's 2. 23 minus 21, 2. Do you see a pattern now? They're all 2s. Right? And 93 minus 91 is 2. 83 minus 81 is 2. How many of these 2s are there? How many pairs are there?
No,
Close.
18.
No. It's this. Okay, go. We have 3, 13, 23, 33, 43, 53, 63, 73, 83, 93. So if you count that, that's 10 pairs. So I know it ends with 9, but because you start with 0, count it from 0.
Oh,
0, 3, right? So 0 to 9 is 10 numbers. That's 10 pairs. So you're adding 2 10 times. What's that? That becomes 2 times 10, which is 20. And I gave you a shortcut explanation, but if you want the proper reason for this, this is the associative associative commutative property. So this is not the valid explanation, but this is what you do in work. In practice, what you do. But if you want a proper explanation, it's actually that you've got is converting into additions with the negative. Because if I do the negation, it becomes -1, it's -11, it's -21, so on. So all of the sub numbers you subtract become the negations of themselves. It's -31, and so on. And then when you add them, 3 plus -1, this sort of cancels out a bit. Right, but that's unnecessary explanation. I think if you do it just pairs like this, that's perfectly valid working, right? So this is a bit of a tricky one, but we can do a few questions like this. Hopefully you get good at these type of things. All right. Okay, we'll get started now. So we had a bit of a long one, but I think spending long time on negative questions is really important because getting head around negatives is a bit tricky. Right? Okay, so now we'll get to commutative property, associative property, subtraction. So I know we did a couple of these questions in the quiz, but I didn't explain them how to do them before. Now we're going to go through them properly in the work. All right, so I think we started last week with the associative and commutative property. Is that because of the new definition of subtraction, right? A minus b is a plus negative b. What we can do is we can rearrange. Once you convert it into addition, you can move them around comfortably, right? Because normally subtraction you can't move around. You gotta be careful when you move around. When you convert into addition by the negative, you can move them around pretty well. So this is, okay, we're starting on page 7 of your second handout from last week.
oh, I forgot it because I was going to do it.
That's all
I
good.
have a book.
Your book? All right, that's fine. For those online, this is page 7 on the second handout. All right. The other hand. All right, so I'll go over this question again, basically. So the point is that since we know the associative and commutative property, we can rearrange subtraction, which we saw already in the quiz, so it's not anything too new, right? But I'll go over this example we went through last week. 232 minus 427 minus 232, right? If you notice, the idea is that these numbers are basically the same thing. They're the same thing but opposite signs. So you feel like they should cancel somehow. But obviously subtraction you can't move around. What you do is you convert them into addition problem. So it becomes 232 plus negative 427 plus negative 232. Right? And then when you do that, you can use which property to go from here to here? The commutative property, right? Remember addition, you can move it around. Learned this a while back. Commutative property to move from here, switch these two around basically. Switch them around, you can see that 232 plus negative 232, when you add them together, they cancel. It just ends up being 0 plus negative 427. That's just negative 427. It's very similar to the second last question on the quiz, right? All right, so now we can use this property in a few problems here. So I'll let you guys practice a bit more with these 3 questions. Can you guys do these 3? So there's nice pairing numbers here. They just have to figure out how to cancel. Like first converting to addition, then moving things around. First one looks good. She'll say something. No long subtraction allowed. Long subtraction is boring. We have computers for that. We need to figure out how to do the shortcuts. So for those online, if you didn't hear that, no long subtraction allowed. You gotta come up with a way to do a shortcut. Even for C. First look at the example. So if you're struggling with it, look at the example, put it up. Actually. Let's see how it did this. It's almost the exact same steps. To be careful. The first one's a negative.
This one.
The first number is a negative. It's negative 1, 1, 1. I think you answered correct if the first one was positive, but it's not.
But on 2 isn't like. Oh.
So here, the thing in this example is that these two numbers cancel out. So that's only this one. Right? So I moved them out from the cancel numbers. Let's do that. This is something like that here. So you pass the cancel to that. obviously I did the wrong way around, but that's a concept, right? Those two cancel out. Makes sense. Why is negative and positive? Well, what actually mean by canceling out? It becomes 0. It becomes 0 minus 2994.
Oh,
It's not that there's nothing, it just becomes 0. So it's 0 minus 4. So let's find positive and negative for that question. So you gotta be careful. Why does it become minus for that? If you have a reason for it, just say. But it's just because the last one is negative. So think what I mean by cancel is the numbers, the other two numbers cancel and become 0. That's 0 plus that 1493. Makes sense? So like it's not just cancel and become negative. It's just the other one's cancelled and now you left at 0. You're adding 0 that whatever that number is. Towards the answer to be negative, positive. Negative. Why is it negative?
because it's minus 12. Then I go to
But why is it minus 312? Where'd you get 312?
this.
But they become plus 2. Okay, so no longer addition allowed.
Oh,
No longer subtraction allowed.
oh,
Yes, this cancel things. Just like when you did the first one, see which ones cancel each other out. So I'll go through part A now. 1247 minus 2994 minus 1247. Right. Obviously, I can do the long one, but I'm going to just do it the short way. Basically, the key idea is that these two numbers are the same but opposite, right? Then opposite, by simply subtracting, they become sort of opposite when you convert to addition, right? So when these two subtract, they cancel each other out and become 0. Right? And you're left with minus 2994. 0 minus 2994 becomes negative 2994. Very similar idea for part B. Right? But I would recommend convert to addition first, just because there's a negative of a subtraction. Right? So it's ideas that matter here, right? The idea is the negative 1181 cancels with the, when you, sorry, I'll do one more step. If I just get rid of the subtraction, it becomes negative 1181 plus 1493. What subtraction of a negative become?
Positive?
Yep, sorry. Oh, positive, yeah. Becomes addition. Two negatives become addition, basically. Right? So we're subtracting a negative becomes addition. And then when this happens, what do you notice now? Do you see any pairs that we can do and cancel it out almost? These two, right?
Cancel out the 1181. Then we'll get 29. And then because you had a minus in front of 1181, it might be negative 1493. Maybe. I don't know.
Oh, okay, so that's where some of you guys get a negative. But this negative applies to the 1181, not to the 1493. The number in front of the 1493 is a plus. But when you cancel this out, this whole thing goes away. So that just becomes 0. And 0 plus 1493. But it will make a bit more sense if I explain like this. If I rearrange it, right? So I'm giving a shortcut to do it, which doesn't explain everything fully. But if I do it fully, it'll make a lot more sense. It's just not useful in practice as much. It's to rearrange them directly. Using the commutative property, I just move them around. But obviously this is kind of long and annoying. Right? So this just cancels out directly then. And you just have to do the 1493 by itself. But it's kind of annoying to do that every single time you do an addition question. So just think of it this plus is the sign. The sign in front of 1493 is what matters that. The sign in front of the negative 2994 is what affects that. So that sign stays with it. The sign in front of it is what affects it, not about the signs. So this negative won't affect the 1493 because this negative goes away when you cancel, and these two cancel each other out. So it's a bit tricky, but the proper reason is when I rearrange it, but you can just think of it as the sign in front is what matters, right? Does that make sense? All right. Now for C, we'll have a break. And if you guys were interested in, because this C tricky is optional, where you can go for it. Have a break for 5 minutes and we'll come back. Yep.
Can I do it like this?
Take a look.
Try to remember what it was, like, a long way, but-
What's 75? Where's this one? Very good idea.
I remember some of my numbers. Like, I feel like
Yeah.
I don't know.
They all do it. They don't go. This cancels. This cancels. This cancels. Is there any other number left? They all cancel. So 3 versus 100. Do these exist in here? Do they cancel? So, you already done this. So these two cancel, become 100. These two cancel, become 100. These two cancel, become 100. 100, 100. You done? You need to add the 6.5. Do you want to hit for C? Do you want to hit for C or? Does it make sense? We don't need to do any more. Just they all cancel it out. Or
So what if this be this?
yeah. I want you to understand that. Just
Okay.
because you don't need to add these. They already canceled out. Yeah. Very good. It's a very good idea. So are you doing C? So it'll be a nice number in the end. You just have to come up with the idea to get that nice number. Do you think the cats are going to make the 8? Do you think the cats are going to make the 8?
I don't think they can anymore.
Yeah.
They have to win against Owen by
Yeah.
50 or something.
I reckon Collingwood's gonna like, even though like they're first in the ladder, I reckon they're gonna like thump this grand final. Because most of the time they always like get like first and then they just lose.
Yeah, and they also lost like.
They lost like
and-
27 grand finals. It says on Google.
Oh geez. I don't think a lot of teams have been there.
We need to win by big margin to at least get top 8 against Owen, but that's going to be hard.
Yeah.
Do you support Caps? Not good enough.
You reckon?
Listen.
Ryan, it's on the right track. So that looks like, but it's not. There's no negatives because the first number is always bigger than the subtracting numbers. Yeah.
goes to my laptop.
Yeah, sure. And Ryan, there's 3 pairs of them. So the pairs add up. The 3 like pairs that are the same. Are we pairing them up?
Yep.
Right here.
1, 2,
Where the bomb is now on the table.
12, the 13, no, the 12. They're like right above Richmond.
Oh, they could go above Geelong this week.
Of course they're better. They're them. Sydney Swans should have won the grand final last year. Not the Cats.
Should have.
Should have.
They got destroyed.
They should have.
How could they?
Well, last year in like round 2, Geelong Cats lost to the Swans. I don't know how it happened like in the grand final. Yeah, they're like
Cats got
not
better.
worse.
The Cats were just so good at the end of the season. They lost like didn't lose a game for like 12 or 13 matches, I think. They won like 12 in a row, right? At the end of last season. There's a lot in a row.
Should have lost. Oh yeah, there's some Cats players who went to my school.
Oh, really?
Yeah, they have like a AFL Hall of Fame in my gym, and there's like a lot of footy players there from like the Cats.
Oh, like any recent or?
Some from like there's one Essendon player from like 2016.
Oh.
Class of 2016.
You should be in the top 8 there, because we bet Port Adelaide. They didn't go down any. They only like lost 1 place.
They weren't lost 2, they were second before.
Yeah,
they're
they're
fourth.
second. Yeah, they're like 5th.
They're 4th.
Oh yeah, it's Melbourne who's second.
Well, where's the
Melbourne, Brisbane, Port Adelaide, Giants, something else, and Saints. That's like the top 7. Oh no,
Essendon?
Carlton's 5th.
Who's gonna win the flag then?
Port.
Port?
Even though we won it, they're midfields.
I thought we won yesterday after the first quarter.
I was watching the match online on my iPad yesterday.
Yeah.
You know, Ash's sister,
Yep.
Dilsha. Yeah, we went with them, and Dilsha's friend and her were sitting like a couple rows down, and it was just me and Ash. And one like the first goal, he was screaming. He stood up and he was screaming.
And everyone else was calling with supporters, right?
Yeah. Even though we were in the Geelong Cheers side, everyone was calling the place.
Even there?
Yeah, it was all calling the fans.
Oh,
And like every time Geelong had a shot on goal, you could hear.
Yeah, I heard it as well.
Everywhere.
even on TV, I heard it. That was loud.
Good thing Collingwood won yesterday.
Do you hate cats?
Yeah.
This is more just, you don't just like a club, you just hate the cats though.
Yeah, exactly. I hate Carlton and the Cats.
Wait, why?
I just don't like Carlton.
Okay.
Sam Draper should have won the Brown.
Okay.
The ball came like a seat in front of us.
Oh, wait, who's kick?
It was a Collingwood kick.
Oh. Alright, so we'll get started again. So Arjun, Ryan, are you guys back?
Yeah.
Okay. So now I'll just quickly go over this one. If you guys have, like, I won't have time to go over fully, but First of all, I'll say the answer to this one. It's actually 300. So Ryan, you had a very good idea. You said something to do with 100. And that's correct, because the idea here is that this pair, when you subtract, becomes 100. This pair, when you subtract them, becomes 100. And this pair, when you subtract, becomes 100. Right? Because look, 268, 168, they're 100 apart. 1375, 1275, 100 apart. 6179, 6079, 100 apart. So we have three pairs of 100. So 268 minus 168, you can think of it as becoming 100 also. These two cancel and become 100. 1375 and 1275 cancel, and they become 100 plus, because 1375 is bigger. So we subtract from the bigger number. 6179 minus 6079 becomes positive 100, so it's plus 100. And when you add these three up together, it becomes 100, 100, 100. That's 300. Right? So in the end, no long subtraction needed. You just need to be clever with which numbers you cancel together. Right? Because long subtraction, unless I really, when you have like at the basics, we're not going to do that because you guys already know how to do that. So we're focusing on other ways to do subtraction. We're trying to become comfortable with numbers so that later on, the other concepts we do, we can become easier. All right, any questions with what I did there? No? All right, so we'll move on. Actually, we'll do couple challenge problems, then we move on. Next topic. So very similar ideas here. I'll go to this example first, right? So remember a question like this, we have a lot of numbers that are together and a lot of numbers subtracted together. First of all, long subtraction, you can do it, but you really want it so many numbers, right? So we're gonna come up with a couple of ways to do this. So the idea here is very similar to the question before. Here is that it's for you to notice what do you notice about these numbers? Yep.
Every number is like on the left side plus 1.
Yeah. Number on the left side is one more than the corresponding number on the right side. 19 is one more than 18. 28 is one more than 27. 37, one more than 36. 46, one more than 45. So when they subtract, they all cancel out. They all become one, basically. So you're gonna end up with a bunch of ones in the end. So this cancel, this minus this becomes 1. This minus this becomes 1. You have how many ones? 1, 2, 3, 4, 5, 6, 7, 8. 8 pairs, 8 ones. What does that add up to then? 8. All these huge numbers just end up being 1 because there's 8 ones there. 8 of these here. Does that make sense? So it's these type of ideas you need to cancel, do mass cancellations. All right. I'll let you guys do the next two questions. Are very similar. A and B. Very similar ideas. So I know it's a new idea, but try to just apply what the ideas we talked about here now, the example, to these next two questions. Five minutes.
Can I go to it?
Yep, sure. How many pairs are there? We can't go on to 59 numbers. It's a practical 49 for the number of numbers. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Just counting how many numbers. your idea? So keep on the right track and work. Yeah, pairs, yeah. Just need to find how many pairs there are. Right? So you're on the right track. For those of you online, do you guys want to hint or anything? Or
What did you say?
do you guys, if you guys want to hint or anything, please let me know if you're struggling a bit.
I sent you the answer.
Send you the answer. All right. Oh. Oh, could you send you the host one this time, sorry?
Okay.
Sorry about that. Should have told you before. Just need to, what are those 10,000? What are those 10,000? 2,000. I mean, it's hard to imagine 10,000, but maybe do like the first 10, and then go bigger from there. Get the idea first. Maybe do first 10 even minus first 10 odd. See what's going on. What are the first 10 odd? Even what are the first 10 odd. And then you maybe see something. Like, I'm not telling you to solve it yet. This is a big problem, right? But if it's hard and it's really complicated, you can do a very similar problem. So this is actually for everyone. Whenever it's a long, tricky, hard problem, right? Instead of doing the problem directly, what you can do is do a smaller but similar problem. So I know I've asked the first 10,000 even numbers minus the first 10,000 odd. What you can do is do the first 10 even minus first 10 odd. But then you see patterns there. Right? And then when you see from that pattern, you go up to 100, up to 1,000, up to 10,000. Right? Does that make sense? What I'm, sort of the idea I'm giving you?
Yeah.
So this is just a C pattern, then you can go from there.
Can you like help me?
Yeah, sure. So, very good. First one is good. Is that 4A? Arjun?
Yeah.
Oh yeah. That is close, very close. But how many pairs are there? What you need to think. See,
50? 100.
that's 50 pairs.
Yeah.
50 times whatever the difference is. It's
100?
not. Yeah. So that's your answer. So you got to figure that out from there.
Oh.
Right. So, figure out just the difference. 100 and 50 was less. And don't forget the sum of the first. So you add all these up together and subtract. Add all these up together and subtract. But don't do it that way. That's another thing. Come with shortcut. Just like the way here, you can add all these up together. We try and generalize 10,000, right? You don't want to see 10,000, you want to do it that way.
Can I go to the toilet?
Yeah, sure. Very good, Arjun. That's correct. Yep.
So it would be the same number all the way, like the difference.
Each even number is one bigger each odd number. Cool. Which one's the answer to A? A or B?
Oh, for it.
A? Is it this here?
Oh, I thought I had to like add the thing like two.
Where did you get the 50 from?
Oh, because I had to do the right numbers.
Yeah, but you don't add all the, or did you add up all the ones on the left? Add up all the ones to the right?
Yeah. Like
You don't need to do that though. It's the pairs. Remember from the first question, the pairs and subtractions,
Oh,
and then find how many pairs there are.
Yeah.
Very similar idea here. So you see which pairs subtract to y, and then if they're the same, you can pair them up and cut them up nicely. How are you two going with B? Oh, 5 for the first 5. Right? Yeah, we don't have to do manually. You can see pattern. Do quickly if you see pattern. So this is the first 5. Even minus first 5 odd. What does that give? But this way. With first 5 even numbers. Difference is 5. It's first one that way. It's going to be. Very good. Yeah. Because you saw the reason is the pairs drop over to 1, right? Does it change just because the number gets bigger? It's because there's 10,000 even numbers. There's a pairs difference change. A difference between the pairs, so they change. If I go to like, there's 10,000 even number, or right? And 10,000 odd number, what's the difference going to be? So it's always 1. See how many pairs at 1.
What do you remember finished A and B?
Sorry? Sorry, I didn't hear that. Could you say that again, please?
What do we do when we finish A and B?
I can just relax. We'll discuss them now.
Sure.
So, what about you, Johnny? Do you see? You have to be? Okay.
I'm just stuck in that.
Okay, so it's very similar. It's very similar. It's just a word problem version of this question. Trying to come up with similar ideas again. All right, so we'll discuss this issue now. So 201 minus 101 is 100. Right? What's 202 minus 102? Also 100, right? 203 minus 103, also 100. And every single one of these pairs, when you subtract them, they become 100. So you have how many pairs of 100? 50. So 50 times 100 is your answer. It's super easy, right? Just 1 times 5, and you add a zero, a couple of zeros. 5, and how many zeros are there? 1, 2, 3. So 5, 0, 0, 0. That's the answer to A. So for B, I'll show you the case of the first. I won't give you the answer to B right away. You haven't done it yet. But if I do the first 5 even numbers, right? 2 plus 4 plus 6 plus 8 plus 10. I subtract from that the first 5 odd numbers, 1 plus 3 plus 7 plus 9, right? Look at this. 2 minus 1 is 1. It's 1. 4 minus 3, 1. 6 minus 5,
1.
8 minus 7, 1. 10 minus 9, 1. How many pairs of 1s do you have?
2.
So you have 1, 2, 3, 4, 5 pairs of 1s. First 5 odd numbers. First 5, for the difference between the first 5 is 5, because there's 5 pairs of 1s. Difference between the first 10 is also going to probably say this, because the idea extends, right? Always this even number is 1 more than the odd number. 6th even number is going to be 1 more than the 6th odd number. 7th even number is going to be 1 more than the 7th odd number. The difference is always going to stay 1. Each time you add an even number and you subtract the odd number, you can only keep adding 1. So when you go to and you have 5 even minus 5 first 5 odds, it's 5. You have 10,000. Difference is going to keep increasing by 1 and 1. it's going to come to 10,000. So you can't calculate this directly. It's more if you have to come up with the idea and just extend it. Because obviously writing down this, it's not super hard. You're not going to write down 10,000 numbers and add them all together. Key idea is that the difference always stays a 1. So you just keep adding 1 each time, basically. So you have 10,000 pairs of 1s. You think, like, I know I should only show the first 5, but the key thing is that the idea extends to all the way until 10,000 numbers, even a million numbers, right? If I added the first million even numbers and I subtract the first million odd numbers, what's that going to be? Anyone? So you can say it out loud. Think about it. It's going to be a million, right? Because each of the 1 million even numbers is 1 more than the pair one. So it's just 1 million pairs of 1. So this is not easy because you can't write them down and calculate it tangibly. It's just idea. You have the idea there, right? Each one's 1 more. So then you have a million pairs of 1. When you subtract, they become 1s. Does that sort of make sense? Or so just look at the first 5, right? Each of the first 5 numbers, 2 is 1 more than 1. 4 is 1 more than 3. 6 is 1 more than 5. 8 is 1 more than 7. 10 is 1 more than 9. If you keep going, 12 is 1 more than 11. 14 is 1 more than 13. Keeps going. All of the even numbers, yep, is exactly 1 more than the corresponding odd number. So when you have the 10,000 even number, that's 1 more than the 10,000 odd number. So all there's 10,000 pairs of numbers that have a difference of 1. Right? If I got whatever the 10,000 numbers is, they're just 10,000 pairs of 1. So it is a bit of a tricky idea, but try to wrap your head around that, because I can't write it out. I just can't think about it. It's a bit tricky. Okay. If it's still not fully showable, it's fine. This sort of ideas we'll talk more and it'll make a bit more sense later on anyway. All right, so now we'll move on to the next concept, which is subtraction and the distributive property. All right, so before we do this topic, I want to talk about distributive property. You'll recall it, distributive property for addition and multiplication, right? We did this a little while back, but do you guys remember how we used the distributive property for addition and multiplication here? Cool. If you have like a times b plus c, it becomes a times b plus a times c. Remember that property we did the first, I think, second week or third week? Second week, yeah. Remember that? So you need to remember that one. For example, I'll give you an example of that one. 13 times by 43, 67, right? So I'll do it all the way around. 43 plus 13 times 57. If you calculate this directly, it's hard. What you can do is you can take out the common factor of 13, use a distributive property, add the other numbers together. Remember doing stuff like this? And you get a 13 times 100, which is just super easy to do. Right? So this property, we're going to use that now, but we're going to do that with subtraction. So since we know that the distributive property works for addition, it's only logical to go and check whether the distributive property works for subtraction, right? And if it does, it can be useful. We can save a lot of time. We're going to do a few problems related to that now. So we're going to calculate 13 minus 3 times 4. Can you guys do these 2 examples? So 13 minus 3 first and times 4. And 13 times 4 minus 3 times 4. That's good, Arjun. This is an example, so just should be pretty simple. I think you gotta be careful. Use BODMAS, Arjun. By the way, Ryan, if you have texted me, I might have missed it. Could you send it to my host account. Right.
Okay.
All right. Sorry about that. I think you sent one before that I didn't see. So for A, yeah, that's good, Ryan. 13 minus 3 times 4. 13 minus 3 is, yeah, the answer is 40, yep. But if you do the brackets first, just do it like slowly. Times 4, 40. Right, so that's 40. But if you do the other way, yep, that's good, Arjun. And if you do the other way, which is 30 times 4, that's 52. Minus 3 times 4 is 12. 40. Good. What does that say? Are they the same? They're the same. For C, do you think this property that we saw, like where it's these two are the same thing, do you think they'll work for any three numbers? If I have, A minus B times C, is that equal to A times C plus minus B times C?
Depends.
Does that depend? What does that depend on?
Oh no.
All right, because it works for addition. It's pretty like subtraction very similar to addition. So it's like we can almost think it works, but it's good to challenge it, right? Because before you use any property, I want you to understand it, right? So don't just take my word for it, right? So here is, I'm going to prove it to you now why it works. So don't just take my word for it. At the start, maybe when I did addition, take my word for it, just because I can't really prove addition to you. But later on, when we get to harder topics, always I'm going to prove it to you so that you don't just take my word. You should be always questioning what I do, right? So now here's my reason to you. And if you don't like the way I prove it, tell me now, all right? So the only thing I'm going to use for this proof, let me see the chat first. All right, good. So everyone that did well, both Ryan and Arjun. Here's my argument. So, but first of all, for my argument to work, you guys need to always, do you believe in the normal distributive property for addition? You trust that, right? That's the only thing I want to introduce. Do you remember the new definition of subtraction? Plus negative, right?
Yeah.
So it's plus negative 1. Okay. And now, since it's addition, I can use the distributive property like normal. All right, so it's 3 times 10 plus 3 times negative 1. So far, so good. And then 3 times 10, actually, I'm not going to calculate that, but that becomes 3 times 10. And then 3 times negative, what does that become?
Negative 3.
Yeah, so it's plus negative. I'm going to say keep times 1, but it is negative 3, yes? If I'm adding a negative, what does that become?
Negative plus negative.
Negative plus is subtraction. You're subtracting a negative, subtracting positive. So if I'm adding a negative number, that becomes same as subtraction. 10 minus 3 times 1. And look, this has come to this using just the rules we learned so far. I didn't calculate any of the numbers. I just used the rule to prove it. And now I'm going to show the same thing with just this one. Actually, can you guys do what? Actually, don't worry about that. That's proof. We don't need to worry about that. But I'm going to do the same thing with any number, right? It doesn't matter. But I follow the same exact steps as I did here. I'm going to get to proof of this, right? So I'm going to convert this into addition. So then I can use the addition distributive property. A times B plus negative C. Then I can use addition distributive property. A times B plus A times, I'm just distributing these two around, right? A times negative C. And then I just use, if I subtract a positive and a negative, it becomes negative, right? It's negative A times C. If I'm adding a negative, that becomes, by definition, for new definition, A minus B is A plus negative B. If I'm adding a negative, that's the same as subtraction. That means this becomes A times B minus A plus C. That's a property we need to prove, and then we're done. Right? So some of them might not have made fully sense, but if you have any questions, let me know. All right, you guys trust this now? All right, good. So you don't need to prove this. You don't need to use it, but I'll just prove it for you, just for the sake of it, right? So here is it in full writing. But now we're going to apply it to a few problems. Actually, we'll watch the video first. Oh, I need the link. I think I'm on YouTube. So we'll watch this video.
Hi, my name's Adam, and I'm one of the chiropractors here at Wellbeing. Our locations are
Okay.
Times 13, that's a drag. 59 times.
Okay, so for those online, let me know if you can hear this. The audio working fine?
Yes.
All right, good. So we'll another perspective on this.
Multiplication and addition together again in the distributive property. But does this work with subtraction too? Let's check that out. If I start off with something like a times b minus c, well, the distributive property doesn't tell me anything about subtraction. It just tells me about addition. But subtraction is the addition of a negation. I can turn my subtraction into an addition. I can write this as a times b plus the negation of c. So now over here I have an addition. I have a sum, so I can use the distributive property. I can use the distributive property to expand this as a times b plus the product of a and the negation of c. So a times b, well, that's just a times b. A times the negation of c is the negation of ac. And of course, if we're adding a negation, that's just subtraction. That's what subtraction is. So that gives us AB minus AC. And sure enough, multiplication distributes over subtraction just like it distributes over addition. A times the whole quantity B minus C is A times B minus A times C. Now, of course, because multiplication is commutative, we can switch the order of these. I can write this as B minus C times A, and that equals, well, I can reverse the order of each of these. B times A minus C times A. So I can have the subtraction on the left or on the right, and I can use the distributive property to expand, to multiply it out. We call it expanding when we go this way. When we come back this way, we call it factoring. We factor out an A to write this difference as this product. Now let's put this to work on a couple of problems. Oh, that looks like a lot of work. We didn't come here to do a lot of work. We came here to do a little bit of work. Well, at least no more work than we have to. I hear you, right? You're willing to work, but you don't want to have to do work that you don't have to do. So we don't want to multiply this out. 79 times 13, that's a drag. 59 times 13, that's a drag too. 13's in both of them. We can use the distributive property. We can factor out the 13. We can take out that 13 and write this as 79 minus 59 times 13. And all we're doing there is using the distributive property. We're factoring out the 13. 79 minus 59, well, that's 20. So our problem is now 20 times 13, and that is easy. That's 260. And we're done with that. Ready to go to the next problem.
Does that make sense what it did there? Just factor out the common factor of 13.
Yeah. Wanna go to the toilet?
Yep, sure, go for it.
Oh. Who thinks of these things? This is ridiculous. This will take all day. I mean, it's not like how. Well, we're doing a distributive property lesson, right? So we're gonna. I don't have anything to distribute. Multiplying by this ridiculous number is hard. That number's close to 1,000,000. I can multiply by 1,000,000 all day long, just throw on some extra zeros. But this isn't 1,000,000. This is close to 1,000,000. It's only 2 away from 1,000,000. Well, I'm going to write this down in terms of something, well, at least I know how to deal with 1,000,000. So I'm going to write, it's 1,000,000 minus 2 times the 335. Ah, distributive property again. I can expand this to 1,000,000, all those zeros, times 335, minus 2 times 335. These products are easy. They're way easier than that. This is a lot less work. We like a lot less work. So we multiply these, multiplying by 1,000,000, that's easy. We just throw on a bunch of extra zeros. That's 335 million. And we're going to subtract from that 2 times 335. That's 670. 2 times 300 is 600. 2 times 35 is 70. So we're going to have to subtract from this huge number. We're going to subtract 670. That's pretty simple. We can just, it's going to be a we start off with 335 million. We subtract a pretty small number. We're going to get something that's a little bit less than 335 million. 99, and back here we're going to have 330. And we want to check this real quick. We add it back up, 0 and 0, 0, 3 and 7, that's 10, 0 carry the 1, 3 and 6 is 0, and then we keep carrying the 1s. Get 9, 9, and it all adds up. And there's our answer.
Crush that by just long subtraction, right? You can use long subtraction there, right? But he converted this huge number, it's nearly like 1,000,000, but into a really easy one just by, because most of my millions super easy. You had to adding a bunch of zeros. So when you have these sort of big multiplications, you can use the distributive property to make it a bit easy.
134,999,330, and we are done.
Okay. So that's the lesson on that. So he proved it again, but also he did a few examples, right? Now we can also do, oh, sorry, turn that off. Stop sharing now. Yeah. Okay, so now we're gonna start applying this property, the distributive property. And by the way, is it fine if we go a few minutes over time today, about 5-10 minutes, just because we did the quiz and stuff? Fine with everyone else? Yeah. What about Ryan and Arjun? Fine with going about 10 minutes over time?
I think so, yeah.
All right,
Yeah.
okay. All right, sounds good. So now we saw a few of the way he used the distributive property, right? We'll go over them again. So the question, I guess, is how do we use this? So we can convert, like we did before, he can convert sort of a lot of multiplications that are kind of annoying into one sort of easy multiplication. So for example, here in this example, what I said, I messed that up, that's my bad, I'll do a different one. That's addition. So 34 times 15 minus 14 times 15, right? Think of this example. Doing this by hand, directly just calculating this one and subtract from this one. You can do it, but it's kind of annoying. We don't want to do that. What we can do is we can factor out what number can we factor out? Yeah, 15 is the common factor. It's just distributive property, right? So we take out the 15. But inside the brackets are the numbers. So it becomes, what does it become inside the brackets? We take out 15 from the first one, with it, 34. 34 here.
34 plus minus 14 times 15.
Yeah, so it's minus 14 in there. So it distributed out, took out the 15, put the other two numbers inside the brackets. All right, and then for 34 minus 14 is 20, right? 20 times 15, and that's super easy. Right, that's just 15 times 2 and add a 0 to it. So that's just 15 times 2 is what, 30? And add this extra 0, 300. You see, I could have done it this way, but I just did this way, and it's a lot less work. A lot nicer numbers. And another useful thing about this is this can reduce a lot of silly mistakes. A lot of times when you go to AS 8, 9, 10, when you're doing harder maths, the addition and subtraction are like little glue steps. They're not important, but you just need to do them. So if you know about these properties, you can save a bit of time and make less silly mistakes. A lot of people make silly mistakes and add and subtract really big numbers. So you can avoid this by doing these type of things. All right, now this one's wrong. Should have done. And let's do 39 times 18. So I can do this. Long multiplication is possible. Actually, I'll do it a bit bigger to make it more annoying. 99 times by, I'll do 39 times 18. 37 times 18. I can do this, but I can also do it the other way, which is if I can split this up into a smaller one, which is 40 minus 3, right? Because 37 40 minus 3 times by 18. And I can just do 40 times 18 minus 3 times 18. Obviously, you don't have to do it, but sometimes when it's much bigger, I'm just giving a small example, but it's much bigger, this might be a lot easier, right? And this just becomes calculate them individually and so. Right, 40 times 18 is 4 times 18 is what? 72, is it? 14 times 4. 4 is 32, 2, 3, 7, 72, yeah. 72 at 0 minus something. So you can do it this way, but obviously I think this one is the more important one. So you know how I said we could do cool mental math tricks when you do addition and distribution? You can do the same thing here. So I'm gonna ask you is I want you to give me, I'll show you what I'm gonna do, calculate. You give me any number from 10 to 99 here for this here, and I can multiply by 99. I'll give you the answer in 5 seconds.
11.5.
No, whole numbers.
Oh.
I can't do. Give me a whole number. Yeah. 5148. 2 times 99, 5148. You can check if you want. How do I do it? This question. So I got it correct, but how do I do it? So the here is the second use of the distributive property. 99 is 100 times 1 minus 1. Right? So I didn't calculate 52 times 99 directly. There's no way I can do that. What I do is I have it in my mind. 52 times 100. 52 times 100 is what? 52 times 100. If I just use distributive property, minus 52 times 1, right? 52 times 100 is 5,200. Minus 52 times 1, just 52, right? So all I have it in mind is I add 2 zeros to the number you said. So 52, add 2 zeros, 5200. Take away 52. So I did, I sort of prepared this because I knew it was 99. So I sort of did a distributive property in my head to get it. I sort of prepared to do that. So the idea here is that times by 100 is super easy. You just add 2 zeros. Minus 52, minus times by 1 is nothing. It doesn't change anything. So I use the distributive property to get 5200 minus 52. And that becomes 5148. Because minus 52, since I've done a lot of maths, it's not too hard for me, right? You might be a bit slow with it, but even then, you wouldn't take you that long to do that, right? Minus 52. So that's how I do that. Does that make sense? How I use the distributive property for that specifically, though? Yep. Okay. And if you guys want, just for fun, give me a 3-digit number. Actually, I'll do 998. It's a bit harder. Give me a 3-digit number from 100 to 500. Don't go too much higher. Don't go higher.
199.
199.
499.
498002.
That's a bit more than 5 seconds. So it's like 6 seconds.
And I was trying to comprehend the number. I think it's 498002. And I use a distributive property. And we'll check it, right? We won't use the calc. We'll check it ourselves. 499 times 998. What do you think I'm going to split I'm going to write 998 as?
1,000.
Minus
2.
Yeah, exactly. 499 times 1,000 minus 2. And if I did 499 times 1,000, what's that?
499,000. So
Yep, I did that.
400,000.
I just add 3 zeros. Right? And what's 499 times 2?
498. Oh no, it can't be. 798.
No, close. 98's good. What's the first number? Minus 4.
700, 908.
998. Right? 499 times 2 is 998. And then if I subtract this, that's just this is 2,000, 1,000. That just ends up being 498,002. Right? And you know the reason I don't want you to tell me a number bigger than 500? Because if you think you mean number bigger than 500, this number ends up being more than 1,000, and that's kind of annoying to subtract. So I just want to subtract a 3-digit number.
But can you do it like even though it's
Yeah, you can, yeah. And they just the mental trick is hard. But if you do it on paper, it's perfectly fine. Right? But do you get the concept of distributive property? All right, now we'll apply that. Okay, so here we go. Go through this example. So I want you guys to do it with me. Okay. Paper. So I want you to be writing things down, right? So we're trying to do this example, trying to figure out what this is. So obviously we can do it this times this times minus this times this times minus this times this. But we don't want to do that because that's really hard, right? That's not really hard, just time consuming. So instead, what we'll do is what's common factor here on all three? Yep, 23. So I'm going to first of all, actually I'll rearrange it to bring 22 to the right side on all of them, so that then I can take it out easier. I just brought the 23 to the right side. Then now that's common factor of 23. So I'm going to take that out. Take that out 23 here. What do I put inside the bracket?
219.
Yep. And
83
plus or minus? Minus 83, and then?
minus 37.
Yep. And do you guys get what he's doing there? Yeah. But like, why is it minus there and stuff?
Yeah.
Yeah, good. All right, now what's 219 minus 83 minus 37? You can do long subtraction.
Is it 99?
Good. 99 times 23. That's one multiplication, so that's already easier than doing 3 multiplications. But can we make it even easier? Can we make this even easier? Because here we can immediately finish, do long multiplication and solve it, right? But
Yes.
can we do it another way? No,
Make
long,
to 100, then it'll be 2300, and just minus 23 from that.
perfect. 99 same as 100 minus 1. So I do the distributive property by the other way. That just becomes 100 times 23 is 23 with a couple of zeros behind it, minus 23. And now I just apply. I just subtract that. That's pretty easy. Right? I think 2277, right? That's our answer. Followed all the steps there. Does that make sense? All right, now we'll do a couple of questions there. So it's these 4 questions, then we finish, go home. So we just need to apply the rules to these questions. So doing all four. I'll start with these two. All four we're doing all four. But go to the first two, A, B first. That means multiplication.
I was the only one in my class who knew that.
Oh, really?
Yeah.
I think it's more American. It's still used
Yeah.
in Australia, but less.
Yeah.
Yeah.
Less sure.
Which look at your algebra and there's nothing anymore. Multiplication is nothing. They just do A, B, and A times B. Arjun, so your answer for B is good, but A I don't think was correct before. So B was good. A, I think, check over that one again. Because it's subtraction, not addition. So I would say you don't need to do long multiplication yet at all. Maybe a very small one, or use shortcuts. So not fully shortcut, you have to do this. So you did the shortcut there, which that's good. You did A really well. Shortcut. That's good. So you can do that way, but you have to use calculate it specifically, right? Once you use the distributive property, just make it one multiplication. So you know how to calculate these two separately.
Yeah.
But you don't have to do both of those. Use the distributive property. What's common factor? So take that out. Remember when we did the example, we took it out. So there's only one multiplication. And how are you going with this one? Yeah, that's good so far. You need 16 times 30, you can just do 16 times 3 and another 0.
Oh, yeah.
So it'll probably be a bit easier in your head. Yeah, that's good. Arjun, the first one is correct now.
Wait, which one, C or A?
A is correct. I haven't checked C yet. Let me see. Yeah, C is also correct.
Okay.
Oh, careful with the multiplication. 51 times 20. Sorry, I missed that before. Yep.
Times it by this there.
Yeah. So you take it out. So you don't have to cancel it out.
Yeah, you have to take one.
So okay, 10.
So this right.
Yes. That's good.
I finished.
That's good. You can chill for a little bit. We'll discuss soon. And actually, oh, CD. 17 times 5. Don't think D is correct. Maybe look over D again. Wait, no, wait, sorry. That's my bad. It is correct. Sorry. I read that question wrong. You're good. Ryan, you're correct. The first one. All right, so we'll discuss A and B now. So for A, so if you guys are not sure how to should be the working out for this one, also take a look. You want to show nice working out. Obviously, you don't have to do this because working out whatever's comfortable for you. but you can think of it as taking out 51. You show it as just taking 51 out of there, and you put the other numbers inside the bracket. It's 31 minus 11. So ends up just become 51 times by 20, which is 1020. Sorry, 50 minus times 20. I won't do that directly. I'll explain that. Way to do this once. This is not too hard to do with long multiplication, but easy way to do this is to do 51 times 2, which is 102, and then you add a 0 to it after that. So 1 0 2 0. And then for the second one, again for B, it's again the common factor of 16. So you take out, oh, I should move this out of the way. Common factor is 16, you take that out. It's up with 47 minus 17. Ends up being 16 times 30, right? And that ends up being 480. These are the two answers so far for A and B. And I won't show C just because it's the same thing. Actually, no, I will show C because it's 3 numbers, a bit different. Right? So for C, has everyone finished C? Yep. If you haven't finished C, let me know.
I finished it.
Finished it? All right, good. What about you, Ryan? Yep. So if you take out the 13, right? I should take it to the right. It doesn't matter which side you take. You can take it out to the left or the right. It's fine. You left with 117 plus 51 minus 68. You add all these up together and end up getting a what?
100.
100 minus by 13. It's just 13 with 2 zeros on it. 1300. That's the answer to C. So you see all these hard multiplications are made easier just by doing this. 1300. All right, any questions with that? No? Okay.
No.
What about C? What is anyone's answer to this one? Yep.
1700.
Close.
1683.
1683. You did multiply by 100, but it's by 99 actually. Check it out. So the common factor is what here? 17. Yeah. When we take it out, yeah, 5 minus 22 minus 34. And 70, and if you simplify this, 155 minus 22 minus 34, what do you get?
99.
99, right? 1683. Take a look at this one, right? If you take out the 17, you get this one. 155 minus 22 minus 34.
Can I go to it?
Yep, sure, go for it. Minus 22 is 133. Minus 34, that's one more than 33, that's 99. So you end up being 70 times 99. And here you can do long multiplication, or what else can you do to make it easier? If I said no long multiplication a lot, it is, but if I said that, what would you do?
17 times 100, then minus 17.
17 times 100 minus 1. Yeah, exactly. You get 17 times 100 minus 17 times 1 is just 7. And you just do 1700 minus 17. That's 1683. And that is our answer for D. All right. Okay, nice. So that's those questions done. We are 6 minutes over time. But since the reason I wanted 10 minutes was just to get started on reciprocals. Yep. You have a question? Oh no, sorry. Okay, so we'll start talking about the idea first. So this is page 12 now. Actually, is Ryan back? Just because I want to make sure everyone's different to talk about this. It's fine. talk about this next week as well. But so we're going to the fifth topic now, which is reciprocal, right? Reciprocals are really, really important when we get to fractions and also powers next chapter. That's why I'm teaching it to you now, so that it'll be a little bit easier when you get to those topics. So, you know, before we did subtraction, right? We introduced this idea of negation, which you haven't heard before, probably, right? Before we do division, we're going to introduce this new idea for reciprocal, right? Here's the idea. So you know how 10 plus 0 is 10, right? But then what number we need to add 10 to get to 0? Anyone? Yeah, minus 10. That's the idea. What's the idea for this? Negation, right? You have the negation to find the number you add to get to 0. Because 0 is a special number for addition. When you add 0 to anything, it doesn't change anything. 0 is like, it's called the additive identity. Big word, you don't need to know this, but it's called. What basically saying is, when you have addition, 0 doesn't change anything. But for multiplication, is 0 that? When you multiply by 0, do you change the answer? Yes, right? It becomes 0. If you have 10 multiplied by 0, it doesn't come back to 10, it's 0. The number that you need to multiply by 10 to come back to 10 is just 1. Because 10 times 1 is what? 10. So it is 10 is the 1 is a special number for multiplication. But if you multiply by that 1, it doesn't change the answer at all. Right? But what number do you need to multiply by 10 to get to 1?
Negative 10.
No, 10 times negative 10. It's a negative number. That's negative 100 actually. It's not negative 10.
To multiply by 10.
Yeah, to get to 1.
Or to get to 1.
Okay, first of all, it can't be negative because if it's negative, it's going to be negative. But can it be 1? If you multiply by 1, you get to 10. That's already too big. So it's a positive number that's between 0 and 1. So is it a whole number? It's big, it's positive, but it's smaller than 1. So it can't be a whole number, right? Yeah. Okay, all right. We'll talk about this next week anyways. Okay, bye. So what do you need to multiply? So it's a number between 0 and 1, but so it can't be a whole number, right? So all the whole numbers. All the whole numbers are bigger than 1. So we have to come up with a new number. What I'm going to do is we're going to call it 1 over 10. And what it is exactly, it's 1 divided into 10 parts. So this is 0 is here and 1 is here on the number line. 1 over 10 is like somewhere really close to 0, but it's like this 1 divided into 10 parts. Right? And we'll leave it that there. Is 1 over 10. It's 0.1 is the thing, but we won't talk about decimals yet. But let's leave it as 1 over 10 for now. All right, so we'll finish there. We'll talk about the idea first. And we'll talk about this more in depth next week. All right. Okay. I'll see you guys next week.
I got a question.
Yeah, we can talk questions.
Yeah, after us.
Yeah. Well, we're finished now. Do you guys have any questions related to the class? Specific any question? No.
No.
All right. And I'll see you guys next week. Have a good week.
Bye.
Bye. Stop recording.